So my name is Lara Macon. Like Paige said, I'm a range technician at the Jornada. And today I'm going to give my talk entitled Combining Technology and Tradition. So I'll be talking about how to integrate precision livestock management technologies into a range management plan. The work that I'm going to present today has been conducted by many amazing scientists and research technicians at the Jornada Experimental Range. And I will say before we get started, we're still tweaking our methods and adapting things to meet our needs. But I really just want to go through the process of how we structured our adaptive management plan, share some of our successes and failures, and also discuss the challenges of integrating precision livestock technology into our system. So with that, we'll get started. A little definition: adaptive management is a strategy that can help us make decisions, even in the face of challenges and uncertainties, by allowing for increased flexibility. So it involves identifying our objectives, learning from our previous management actions, and incorporating monitoring data back into our decision making. So it's kind of this circular model of planning. When I think about strategies for range management, I love to think of the analogy of thinking of them like tools in a toolbox. So over time, we keep adding more tools into our toolbox. And if we kind of reflect on the last 100+ years, we can see that a lot has changed over that time, but there's still a lot of similarities. You know, we're still conducting on-the-ground field monitoring, we're still using horses and squeeze chutes. So there's a lot of overlap. And although we have lots of new tools today, it doesn't mean that we just go and throw out all the old tools. What we need to do is evaluate, okay, how can we use these new tools in conjunction with our old tools? So some of the new tools that are available today include precision livestock management tools. PLM, or Precision Livestock Management, is the use of sensors and technologies to help increase productivity and efficiency while decreasing labor inputs for livestock production. This is things like GPS collars for cattle, virtual fence collars, water level sensors, as well as tipping bucket rain gauges. And today I'm just going to focus primarily on the first two. At Jornada, we've been using both virtual fence collars as well as GPS collars, and we have them combined into this singular collar unit. That's just for research purposes. I want to make it clear that both the GPS collars and the virtual fence collars work independently of one another, and you don't need to have both systems. So another relatively new tool is remote sensing. It's the use of satellites or aircraft to gather information about Earth's land cover, things like vegetation cover and production. So some examples of some remote sensing products available are the Rangeland Analysis Platform, StockSmart, as well as GrassCast. And today I'm going to focus primarily on the Rangeland Analysis Platform, which we also call RAP. So with these new tools comes the following question: how do I incorporate them into my current management plan? So I'm going to share about how we incorporated remote sensing and virtual fencing into our adaptive grazing management plan at the Jornada. And just to give you a little bit of background, the Jornada is a 300 square mile research area in the Chihuahuan Desert located just north of Las Cruces. It was established in 1912 as a long-term research station to understand how rangelands in the Southwest are changing. So when we go back to our adaptive management circle, the first step is our planning stage. So first off, we need to define what our problem is that we're trying to solve. There's a lot of challenges that face range management, especially in the Southwest. Some of the ones that we're dealing with are increasing climate variability. This means variable precipitation, extreme weather events, as well as extended and persistent drought. We're also dealing with those issues in the context of these large remote landscapes, which means that it can be time-consuming or difficult to conduct on-the-ground monitoring. And we also have limited cellular connectivity in places out here, which can kind of restrict the types of technology that we might be able to adopt. So those are all things we need to be thinking about when we're thinking about planning. So that kind of sets the scene for where we were in February 2024. So we were trying to decide out at the Jornada where we should move our two cattle herds for the spring and the summer. We had just started using virtual fence about 4 months prior, and adopting virtual fence significantly opened up our opportunities of where to graze. And that was because previously we had needed to consider our fence condition. So out at the Jornada, we have oryx, we have flash flooding, and just old age that has really severely degraded our fences. And we don't currently have enough staff to upkeep all the fence repair. So having virtual fence really opens up a lot more possibilities for grazing. We don't just have to look at, okay, what are the pastures that have good fence that we can graze? In addition, we also looked at our precipitation records. So that black line there you see is our average annual precip at the Jornada. It's about 9.6 inches. And over the last decade, about half of the years have been below average. Where we are sitting going into the growing season of 2024, we had just had 4 years of below average precip. So things were not looking great. So we also looked at production data, and we did this using the rangeland analysis platform. What we ended up doing is taking this information and compiling it into a cumulative herbaceous growth map, so we can compare which pastures on the Jornada had more forage. From this, we determined that pasture 19 was an excellent candidate, and so we did some on-the-ground field monitoring, confirmed that what RAP was telling us was true, and we decided that based on the estimate of available forage resources, pasture 19 is where we should move our animals. So it's a huge pasture. It's almost 24,000 acres. The north part has a lot of sand dunes and mesquite, and our perennial grasses up there are things like mesa dropseed, threon, Indian rice grass, as well as black grama. And then kind of in the southern portion, a little bit down here, we have more loamy soils, more draws, and we have things like creosote and grasses like alkali sacchaton and tobosa. So, in addition to its size, also the fact that it has this mirrored kind of landscape makes it a good candidate for dividing into subpastures. We could have different grazing treatments if we wanted, or we just have lots of area in this pasture to graze 2 different herds of cattle. It also hadn't been grazed because of poor perimeter fencing. That whole eastern fence line runs up along a bunch of arroyos, so fence maintenance there is just unfeasible. And we felt like we could effectively use virtual fence in this pasture to contain the cattle in smaller subpastures within that physical fence boundary. So with our pasture selected, it was time to set some objectives for the grazing season. We first wanted to provide adequate forage for the cattle using virtual fence. And we also wanted to use that technology to monitor the grazing pressure in order to protect our range resources. So our benchmarks were to maintain a herd average body condition score of about 5 on our cows, and not to allow more than 30% use of our perennial grass forage base. We set that threshold at 30% utilization based on published grazing intensity guidelines for the Chihuahuan Desert, especially where black grama is present, which is the species you see on the right of the screen. It can't handle heavy grazing. So next, we needed to decide how we were going to monitor in order to determine if we were meeting our objectives and our benchmarks. So we decided that we'd split the pasture into 4 different subpastures, and these subpastures were between 5,000 and 6,000 acres. We had 2 different herds of cattle, so we have our heritage breed herd of Lara Murray Criollo and our conventional breed herd of Angus Hereford cattle. And using virtual fence allowed us to graze them in the same pasture, but to keep them separated into different subpastures. So splitting that pasture into 4ths also allowed us to be able to rotate both herds midsummer, so we rotated them up north. To monitor grazing pressure, we decided that it would be best to focus our efforts on hotspots, or the areas where the cattle were concentrating their grazing. And because all the animals in the herd were collared, we knew we'd be able to tell where the animals had been based off their GPS data from the collars, and therefore we could detect hotspots of use. If those hotspots that we found were visited by cattle repeatedly, we wanted to go out and do some on-the-ground monitoring to monitor utilization. So we wanted to make sure we measured perennial grass stubble height, took plot photos, and did an overall ocular estimate of utilization along 3 25-meter transects. And we hoped that this would be enough information to tell us if these areas were being overutilized. So now that we had our plan in place, it was time to implement that plan. So we first had to make sure that all of the virtual fence collars were functioning properly before we turned animals out. So we went in the app and we checked every collar status. We replaced any non-functioning collars, and we also preloaded the pasture boundary on the collars before turning animals out. That was just to ensure that we didn't have any problems loading the pasture boundary, and that once animals were out in the pasture, we wouldn't have to worry about it. So we had 29 head of Angus Hereford cows and 60 head of Rare Murray Criollo cows. Grazing period 1 was 93 days in length, and grazing period 2 was 68 days. To monitor grazing pressure, we used the Precision Ranching Dashboard, which was put together by Dr. Santiago Utsumi and his lab at NMSU. So the dashboard serves as a central location for ranchers and managers to visualize data from precision ranching devices, like the GPS tracking collar that we had that was on the top of the cow's necks. So this dashboard has a feature that allows the user to select a date range and which individual animals you want to look at, and it will then plot a heat map like you see here. I want to note that we could have also chosen to monitor hotspots through the virtual fence app on our mobile phones. Currently, the particular virtual fence collar that we're using is by No Fence, which is a Norwegian company. And on the No Fence app, although you can view hotspots, grazing hotspots, there's no way to easily export GPS points of those hotspots for someone to be able to go out and navigate on the ground to those spots. So you could use the No Fence app to find hotspots. It would just require you to match up where the hotspots were on the app in the virtual fence app to some sort of other mapping application so that you could get those GPS points and actually navigate to them out in the field. So we selected the top 3 hotspots for each herd for every week, and this was done kind of qualitatively, not necessarily quantitatively. So we would plot the week and all the animals in each herd, and we would look for the largest and densest or the most red hotspots. To be considered a hotspot, we had some criteria. So it had to be at least 100 meters away from the cattle's watering point. And this is because cattle typically congregate around water, and we wouldn't be able to exclude them from those areas anyway. And also, we wanted to make sure that the hotspots were at least 50 meters away from another hotspot. If it was closer than 50 meters, we just considered that whole thing one hotspot. And then, like I said before, we did our on-the-ground monitoring of grazing pressure at hotspots that were visited 2 or more times during the grazing period. So if it just came up as a hotspot once and the cattle never went back there, we wouldn't worry about monitoring. But if they came back to it multiple times, we wanted to go see what was going on. So once utilization at a hotspot had reached 30%, we would build a virtual fence exclosure around it if cattle continued to visit that site. So sometimes building the virtual fence exclosures was kind of tricky because we didn't want the exclosures to block the cow's path to water or their access to resources like shade or mineral. And so since the exclosures would be this new feature in the pasture, we really wanted to ensure that they were easy to navigate around while still excluding cattle from the areas we wanted to protect. Basically, we didn't want to make an exclosure that would result in unnecessary shocks to the animals. So when building our exclosures, and also just when building pasture boundaries, it's really important to remember that the virtual fence boundary has a certain amount of air. So for our no fence collars, this is about 5 to 10 meters of air on average, sometimes a bit more. So here's an example of a hotspot occurring from our Angus Hereford herd in grazing period 2. So there was a hotspot here and where this red dot is, and that was actually centered around these big shady oak trees that were near the road. And so probably this hotspot came up because it was a loafing area. So the animals would go spend the afternoon under the shade where it was cool. And the next week, this hotspot comes up again. But so this triggers a site visit. But if we're going to go out and do a site visit, it doesn't make sense to measure under the shade trees where there's not much growing and along the road. So we'd go to the spot and we'd look at, okay, from here, where does it look like there's a lot of grazing pressure? Where are the animals getting up and going after they've been resting in the shade to go graze? And you can see this smaller hot spot just to the left of the big red hot spot. So that was where we presumed they were grazing, up in here, and that's where we went and measured. In the third week, we see the similar pattern. So they still have their loafing area, but they're getting up, they're going out once it cools down and grazing in the surrounding area. So we once again measured utilization in the same spot we did the previous week, and we had found that the cattle had reached 30% utilization there. So now we needed to figure out how we're going to exclude them. We don't necessarily want to exclude them from using that shade area, or from accessing this road, because this road was how they would get to water, but we want to exclude them from continuing to graze in this area. So we built this exclosure that extended off a virtual fence exclosure that was already present. That's in this blue polygon here. And we left a 30-meter buffer between the road and the shade trees and the edge of the exclosure. And that way the cattle could continue to use those trees, but they wouldn't continue grazing the area just northeast of that hotspot. And the screenshot is from the week after we built that virtual fence exclosure. So you can see that the shade trees are still showing up as a hotspot, indicating they're still being used, but animals aren't spending as long there now, and they're not utilizing any of that grassy area to the northeast. So now this gets us to the final step of our adaptive management cycle. So it's time to evaluate how we did. So in grazing period 1, our Angus had 11 repeatedly visited hotspots and our Criollo had 7. And just to remind you, we actually had more Criollo than we did Angus. We didn't have the same number of animals in each herd. In grazing period 2, both herds had 3 repeatedly visited hotspots, and those are on the map there in yellow. In grazing period 1, of those 11 Angus hotspots, we excluded them from grazing 1 because it had reached 30% utilization. So that is down here, that pink dot. There was also one Criollo hotspot in grazing period 1 that reached 30% utilization, but we couldn't build an exclosure around it because it was right along a fence line and it was along the cow's path to water. So we didn't want to disrupt how the animals got to water, so we couldn't exclude it. In grazing period 2, we excluded each herd from one of their 3 repeatedly visited hotspots. And from the most part, it seemed like both herds self-regulated their grazing and they moved off those hotspots before or nearing that 30% utilization mark. And that makes sense because our stocking density was really low. So it makes sense that animals would move from a previously grazed area to go forage in a new area. So the virtual fence exclosures were successful at preventing further grazing at those hotspots. We can see here, this is a cow that was testing the boundaries of a new exclosure that was built in her paddock. And this is what we like to see. We like to see an animal kind of bouncing around. She's listening to the audio cues. She gets to a point and decides, I guess I can't go in there anymore. And she goes off and grazes somewhere else. So, the next step in our evaluation is discussing amongst each other and our stakeholders, okay, what about our management plan worked really well? And we had several things that worked really well. First off, it allowed us to graze a pasture that we wouldn't have been able to use without virtual fence. And that really saved us during a drought year. We could also monitor pasture use in near real time, which was pretty novel and pretty exciting. We could see exactly where the cows had been, where they'd been grazing. We could see which areas of the pasture maybe they weren't going to. We could use RAP, we could use remote sensing to let us evaluate the forage conditions rapidly, and then that could help us prioritize our on-the-ground monitoring efforts. We could exclude sensitive areas using the virtual fence while we continued to use the rest of the pasture. We could also track animals using the virtual fence, and this helps with any animal welfare concerns. We could see any animals that were lame or sick just from their movement data through the virtual fence collars. And we also saved a lot of time when it came to gathering collars because we could use the collars to locate animals. And that last point, I can't be understated how helpful that was. We saved a lot of time because you could check on your phone and you could see, okay, where's the main herd? Where are the stragglers? But of course, there's always dangers associated with using your phone on horseback. So once we reflected on what worked well, we needed to ask what didn't work so well. And we had several things that came to mind. The first being is that collars broke sometimes, and we needed some sort of facility or place where we could both work on the collars, but get the collars back on the animals if they fell off or broke. We also had some issues with cellular connectivity in some areas. This is something we kind of knew going into pasture 19, that there might be some areas we didn't have good cell coverage. The virtual fence collars that we were using do store data on board. They just need that cellular connectivity to share data, but they would store data on board. And they continued to work containing cattle in the virtual boundary even without cell connection. So we weren't worried about containment necessarily, but because we were relying on getting regular, GPS reports of where cattle had been, it was important for us to have at least connectivity with the collars once a day. So we decided that this was a great plan, and it was kind of this whirlwind summer of testing all these different things. And now that we're reflecting back on it, we needed to kind of create this cohesive workflow structure that we could reference and alter in the future. It seemed to us like we did a lot of monitoring that summer. We were going out every week and monitoring hot spots, and that seemed to be a bit overkill. We decided that we don't need to be going out that often. It seemed like the animals are pretty good at self-regulating their grazing pressure. And also, no producer is ever going to go out once a week out in the middle of pasture to go check grazing hotspots. So how can we create a monitoring scheme that's more streamlined and more feasible? And then we also decided that we should focus mostly on grazing hotspots instead of just all hotspots. If you'll remember from that example I gave with the Angus and the shade tree, that wasn't necessarily a grazing hotspot. It was just an area where the animals were spending a lot of time. So we wanted to know, okay, can we look at grazing hotspots only? So the first two issues in here, we didn't have much control over. There wasn't a lot we can adapt to fix those things, but they're really important to recognize and to take into consideration when we're selecting pastures to graze in the future. The other three issues we were able to adapt to in order to improve our management plan for the future. So that's what we started doing last year. We worked as a team to create this workflow outline that we could modify as needed, and we got everyone to help put input into it, and then that way we could all get an idea of what the repeatable steps were we could take each time when selecting an area to move cattle. We're still adapting this workflow to meet our needs as new problems arise, and I know it's kind of word salad, and this is never what you should put on a PowerPoint presentation, but what I wanted to show with this is that you can make your own flowchart, but it's really nice to have some sort of documentation of, okay, here's what we did this year, here's the steps we took, and then something that you can go in and alter in following years. So, like I said, we also decided that we needed to simplify our monitoring methods. We didn't need to monitor those hotspots as frequently as we were, and so now we have switched to monitoring hotspots after 75% of the grazing period has passed. So that means if we estimated that a pasture could hold cattle for 4 months, we would select the hotspots to monitor after 3 months have passed into the grazing season. But this also means that we could have up to a dozen hotspots or more. We could have way more than 3 hotspots. We still kept the same criteria, so they must be 100 meters from water. They have to be 50 meters from other hotspots. But because we were going to have more hotspots to visit potentially, we switched to a more rapid monitoring protocol that didn't rely on setting up transect tapes. So we now record ocular estimates of key species cover. We take plot photos, we measure patterns of soil erosion and redistribution. and takes double height measures of key perennial grass species only. And this monitoring now only takes about 15 to 20 minutes per plot. It's designed so that the user is just pacing out a grid, no transect tapes necessary. And we found that an observer can visit several hotspots in one day to get an overall idea of utilization. I think we've been able to measure as many as 8 hotspots in one day. And we figured that's good enough to kind of get an idea of what is my pasture condition looking like. And so finally, we wanted to adapt how we selected hotspots so we could just focus on grazing hotspots. And like I said, if you remember back to that Angus example, the shade tree, this is a screenshot of individual GPS locations from that time period. And these white dots here that I've circled, that is by the shade tree, and there's a lot of white dots. White dots represent resting behavior, green represents grazing behavior, and the dark green represents walking. So we can now classify the GPS points that we get from the GPS tracking collars by behavior type, which can allow us to filter them and only look at grazing GPS points to determine where hotspots are. I will say that this is only available right now using the Lara GPS tracking collars and the Precision Ranching dashboard. You aren't able to do this right now through the No Fence Virtual Fence app. I can't really speak to other virtual fence companies about how, if they do any of this like parsing by behavior, but it's one thing to consider and ask if figuring out grazing hotspots is really important. I know there's virtual fence companies, all of them are working on kind of behavior detection algorithms, but that's one thing to consider if that's important to you, finding a virtual fence company that could detect just grazing. So now we are back at our planning stage. We went through this whole circle and we did it all again in 2025, and we're going to do it all again in 2026. So every year we're continuing to change and tweak this adaptive grazing management plan as needs arise, as personnel changes, as environmental factors change. And the main takeaway I want to say is that being able to integrate the precision livestock technologies and remote sensing into this is that we've really improved our ability to be flexible and to adapt. So before I end, I just want to end with a few considerations when it comes to adopting precision livestock management technologies. The first thing I'll talk about is it takes time to learn the system. So our cattle were collared 4 months before we really started using those collars for management. In addition, animals also need to be put through some sort of virtual fence training so that they understand what the audio warnings mean, what the consequences for ignoring the audio warnings, and just get familiar with how it works and wearing the collars. People also need to understand how the collars and the user interface works. You should know how to remove the active pasture configuration from a collar before you need to move cattle. So give yourself some time to adapt to the system, learn how it works, and let your animals get comfortable with it. The next thing to consider is what kind of infrastructure you have versus what might be needed. So this can apply to connectivity. So asking yourself, okay, if cell service is good on my ranch, I can use these type of collars, or will I need to rely on towers for my collars to communicate? This picture here is from an area in pasture 19 I talked about where we had poor cell coverage. So we weren't getting those regular reports from the virtual fence collars. So we set up this cell tower, this cell booster at the cow's watering point so that we could at least get the collars to send data once a day when the animals were at water. Thinking about infrastructure also applies to thinking about working facilities. So you will need a way to restrain animals to get collars on and off. And we had to set up this temporary chute to fix some collars out in the middle of the field. And thankfully these Angus girls were good and calm about it, but that's one thing to consider. You'll also need to consider the time it might take to maintain and repair the collars. It's technology, and technology likes to break, so you'll need to consider how and when you'll be able to repair collars, because everything inevitably breaks. Okay, finally, I just want to leave with a few resources that we found really helpful when it came to precision livestock management. So the first one is Tools for the Beef Industry. This is just like a library of all sorts of information and resources on all things to do with beef production. It goes beyond precision livestock technologies. But if you go down and you click on the hardware tab, it will give you a bunch of links below, including links to the individual virtual fence companies that you can check out. The next resource is the Virtual Fence User Guide, and this is from the Rangelands Gateway. It provides a really great practical and vendor-neutral information about virtual fence. And before, like when I was talking about you need to put your animals through training, they have some good guides about how training protocols work. And finally, the last one I'll share is the virtual fence cost comparison tool that someone put together. So this is a great tool that you can put your own inputs into of your own operation, and then you can kind of do cost comparisons based on quotes you've gotten for the different virtual fence companies available now. I think all these links will be put in the chat so that you guys can access them. And with that, I just want to thank everyone who helped at the Jornada and beyond with this project. It was really a huge undertaking, and there were tons of people involved, and we couldn't have done it without everybody. And with that, I will take any questions.
Okay, we have several questions, so let me start with the Q&A box.
Okay.
Your first question is, are you using No Fence brand of collars? What was the reasoning behind the decision on which brand to go with?
That is a great question. So we are using No Fence collars, which is the company from Norway. We got these collars in November of 2023. And at that time, it was either Vents or No Fence that were the companies in the US. And No Fence was the company that could get us the amount of collars that we needed. It was as simple as that. So today, there are a lot more companies, or I think there's 5 total on the market or 4 total on the market. But back when we first got the collars, No Fence was just really the only option that made sense for our size of operation and that could get us as many collars as we needed.
Okay. It's changing on me. Here we go. To clarify, 30% plant utilization means 30% of the plants plants have been grazed, or does it mean something else?
That's a good question. 30% utilization means yes, on 30% of the plants have been utilized. So we're looking at overall utilization. We weren't looking. That means that some plants were grazed and some plants were ungrazed. Some plants were grazed more than 30%. Some plants were left ungrazed. But overall, we're looking at 30% of the total biomass of that plant was taken away, and we want to leave the rest of the 60%.
Okay. Did both breeds select loafing hotspots equally?
That's a great question. We haven't dove into the data yet to answer that specifically. It did seem, one thing that we did see is that the Angus had more hotspots during pre-green up. So that was grazing period 1. And the Angus had, I think it was 11 hotspots, while the Criollo had 7. In grazing period 2, which we considered that grazing period to be post green up or during green up, both herds had the same number of hotspots. And that's a pattern that we've seen in our breed comparison work previously. It's a pattern that has been observed with the Criollo, also in other countries as well. And as far as answering the question, like, did the Angus spend more time resting than the Criollo? We haven't specifically looked at the data in that. We did find that both breeds were going well beyond 2 miles away from water to graze. So we really had good pasture utilization away from water on both herds.
Okay. This question Might need Brandon's clarification, but wondering why you're not mimicking the likes of Alejandro Carrillo. He has demonstrated rapid regeneration in the Chihuahuan Desert. Great presentation.
Thanks. So I think that question is in reference to if I'm thinking about it right, I think that's more of a high intensity, low frequency model or a mob grazing model. Um, I guess I should let Brandon answer that.
You can have a crack at it, Lara. Yeah, I mean, I guess what I would say is that we have the potential now to do that. And we've at the Jornada for the last several years been well below average precipitation. 2024 was pretty devastating for us as well as many other producers in the region. So that was not a time in which we would expect to see regeneration. And right now, we're just gradually recovering from drought after a decent year last year. But I think going forward, now we have the tools to manipulate grazing pressure, and we also have the tools to monitor patchy recovery. So we do expect, of course, with this kind of grazing management, to be able to see perennial grass recovery in this system.
Thanks, Brandon.
Okay. How many times on average did you have to monitor a hotspot before deciding to exclude grazing? Also, do you have plans to monitor vegetation recovery in virtual exclosures?
Those are two great, really great questions. So to answer the first question, how many times did we have to go visit a hotspot to determine it need to be excluded? Usually we'd go for the initial visit. We weren't at 30% yet, and it would take one or two more visits. So usually we'd visit a hotspot. I would say if you really want an average, it'd be 2.5 times, but 2 to 3 times before deciding, okay, this hotspot needs to be excluded. And remind me of the second question again, sorry.
Nope, you're okay. It says, do you have plans to monitor vegetation recovery in virtual exclosures?
Yes. So part of our kind of adaptive management plan is that when we decide to go back into that pasture again, we will use those areas we excluded or our previous hotspots as our pre-grazing spots to go look at conditions. So we have a lot of acreage to cover out the Jornada, so we kind of need to prioritize, okay, when and where do we go look at recovery efforts? And we decided that a good time to do that is when we're planning to go back into that pasture. We'll go back to the same hot spots, especially the ones we excluded, and do all of our measurements again. Great question.
Have you seen the same grazing hotspots show up in the second year, or were they different between the years?
We haven't gone back into the same pasture yet, actually. So this last year, 2025, we were in a different set of pastures. I would suspect when we do go back into a pasture we've previously grazed, it will really depend on what the monsoon season has looked like. Like I said in the beginning, our precip here is so variable. And so it seems like where cattle choose to go is really dependent on where the moisture has been and where things are actively growing. I would suspect some of the hotspots will be the same, but I would anticipate more that it will be linked to where we've had rain.
What type of cell booster did you use?
Oh,
Or,
that's such a great question.
and they want to know what brand and where did you purchase?
I don't have I was worried that someone might ask me that. I can't remember what the booster was. I can find out and I can report back to you. That was Dr. Tsumi who he's really good at figuring out those kind of systems and how it should all be put together. So I will find out what kind of cell booster it was. We put that there. Also, we had another piece of equipment called a green feed that relied on cell connection to report. So it was kind of twofold why we had a cell booster there. It did allow the virtual fence callers to report, but we're also getting data from another piece of equipment. But I will get that answer for you.
Okay, so what all did you have to do to train your animals to your virtual fence system?
That is a good question. So we used the opportunity for the training protocol. It was also part of a PhD student at NMSU's project. So our training protocol was pretty intensive. But basically what we did is we put all the collars on the animals, we deployed them, and we had them in our pens at the headquarters. So we had them confined in a small area. We put collars on things, made sure everything fit, made sure all the collars were working, but we didn't activate any of the collars. And we allowed the animals in the pen to have free choice access to feed, to hay, free choice hay on either side of that pen. And we just let them get used to wearing the collars for 3 days. And then we activated a virtual boundary that only cut off 1/3 of the pen at headquarters, and it cut off one of the sections that they had free choice hay in. So they could no longer go into that section without getting an electric pulse and an audio warning and electric pulse. And they figured it out really quickly. So we left that configuration on for 3 days where animals still could free choice in the open part of the pen. They could still go feed in the open part of the pen, but they couldn't access this 1/3 end of the pen. After 3 days, we switched that configuration. Now they're allowed to go in that area where they couldn't go before, but they're restricted to where they had been feeding. And we wanted to make sure to kind of keep switching that boundary so the animals could learn where they could go and where they couldn't. As well as at the end of all this, we took away any of the virtual fence boundaries and they had access to the full pen again. Because what you really want in training is you want the animal to associate the audio warning with the electric pulse and that being an area they can't go. You don't want them to associate a physical space that they can't go. Because once you turn off a virtual boundary, you want them to still explore that area and be able to go there. You just want them to associate that audio warning with the virtual boundary. So that worked really well. And then after we did that pen phase, what we did is we turned them out in pasture and we did kind of the same thing. We just cut off about 1/3 of that pasture so they could roam a pasture that they were familiar with, but were just cut off from a section from it. And after we did that, we found that all of our animals were pretty much trained to the system and we had almost no issues with animals escaping out of the virtual fence once we turned them out into pasture 19.
Okay. Did you find your utilization was improved on perennial grasses compared to your previous data before virtual fence?
Oh, that's a good question. We haven't looked at that yet. One thing that's interesting with the virtual fence, and it's kind of novel, is actually being able to know exactly where the animals have been throughout the pasture. Um, Previously, when we didn't know exactly where they were grazing, if we've got animals out on a 5,000 acre pasture, we could kind of go out and we could guess where they had been and find some areas of utilization, but having the virtual fence collars really allows us to see exactly where they've been. So that's something that we're interested in looking in the future and seeing looking if we can detect changes in use on those perennial grass species based on knowing exactly where the animals have been.
Okay. Did forage preferences noticeably changed based on the changes in your virtual fence paddocks?
Not that we observed. You know, animals, not that we observed, no. They did change between grazing period 1 and grazing period 2. That was partly because in grazing period 1, they had access to kind of those more loamy areas, different perennial grass species. And then starting in grazing period 2, we got some late monsoon rains that really started to green things up. So that's when grazing preferences changed. But we didn't really notice a difference because of the virtual fence, I would say.
Okay, with 6,000 acre pastures, was livestock water a limiting factor to distribution?
Yes. It was. That's a great question. Yeah, so each pasture, um, yeah, the water access was the limiting factor to grazing distribution. But like I said, um, both herds still would travel over 2 miles away from water to go forage. Um, so they were using almost the full 5,000 acres that we gave them. I will also say that we were limited in pasture size by the virtual fence itself too, so there is a limit to how big you can make a virtual fence pasture in the application, and we pretty much maxed it out with those 4 sub pastures in pasture 19.
Okay, just a couple more questions I think left. Did you feel that the RAP forage estimates were representative on-site production for the most part?
For the most part, we did. Yeah, especially going into 2024 after those previous 4 drought years. What RAP said is there's not a lot out there, and what our on the ground monitoring said was there's not a lot out there. I think RAP, and this was back when we were using RAP when the resolution was 30 meter pixels, and now we have this product that is 10 meter 10 meter pixels. But for the most part, we felt like RAP gave us a really, really good starting point. We still don't feel like we would just rely on RAP to tell us exactly how much is out there and then use that to estimate how long we can keep animals out there. But what RAP has really helped with is prioritizing, okay, where has where has production been high on the ranch, where has it been lower on the ranch, and then that can inform where we need to go do our on the ground monitoring.